Hello, on this video I want to try and go over creating sounds and sound effects on the Game Boy and its sound registers. So when it comes to the sound registers, each register's bits are pretty much divided into switches really. So from this image here, taken from the GB crib sheet, you can see that this one byte here, which corresponds to register 50, has bit 7 meaning one switch, bits 4 to 6 control some other settings on the sound chip, and so on and so forth. So it's best to understand how these bit switches work. So here you'll see I've got the bit numbers which make up a byte, 0 to 7, and then below I've got what the actual value of that bit is. So lots of times some of these bits will be grouped for certain uses, so only a couple parts of the byte will correspond to certain switches and their use. Here are some examples here. For example, the value of 5 is made up of bits 0 and 2. So when both of those switches are active, that corresponds to value 5. And then 240 is all of the left hand bits of the byte set to 1. And then there's byte 60 and what bits are set to on to make up that value. So when it comes to creating sound, first off, this register here, NR52, should always be set to on before use. So there are some issues here which I've noted. I'm also going through the pan docs to try and help me explain this to you. So the pan docs say that these bits here are read only, whereas the GB crib sheet says they're read or write. What I'll do now is I'll show you an example program which comes with gbdk specifically for the Game Boy, which will be really useful for you to gain an understanding of. So if you navigate to where you installed gbdk and then go in the examples folder and then in the Game Boy folder, and the example is sound. So if you go in there, and then for me I've already built this. For yourself you'll probably need to copy the location, open a console window, navigate to that folder, and then just by typing in make, you should be able to build the program. For me it's saying that there's nothing to be done because it's already built, but if I delete this and then delete the corresponding other files and then do that again, it should, yep, there we go. Now if we run this in Emulicious, now what this program does is it allows you to go through each of the 4 sound channels and the main register here as well, so you can get a feel for the sounds. So if I shrink this down here, in the main controls part of this, I'll go over the controls quickly a minute. So the select button on the Game Boy navigates through the 4 sound channels and the main control page. Up and down changes which switches you can change. Left and right activates the switches and changes the values. So some switches will allow a value to go higher than 1. So it might be that there's a value like in this one here between 0 and 7. So left on the D-pad will subtract the number and right will increment the number, and then pressing the A or B button will change the sounds which are played, or rather will increment the steps. So holding the B button down and doing left or right in the frequency here will cause the frequency to go up in steps of 10. If you hold the A button down, it will go up and down in steps of 100. To play a sound, just press start. I'm probably going to need to restart that again. Hopefully you can hear that sound. So I will go over some of the channel details and then I'll keep bringing this application in to kind of help me explain things as I go. But definitely go to this program and have a play around with all these settings to get a good feel for what they actually do. Also the GB pan docs will be very useful for helping you play around with the different values and settings here. It's definitely easier to get a grasp of how the sound registers work by hearing the output of them, as well as understanding what the switches actually do themselves. So I'll now jump back into here to try and explain some things. So I will also bring this across here as well and move this up here. So when you're creating sounds, always make note of these numbers here. If you want to reproduce the sound later, I would recommend opening up like a text document, and then when you play sounds and you want to make a note of a specific sound, you can copy the numbers out into that text document, because these are the bytes here that you need to load into these registers to reproduce the sounds that you create. So if I go back to the main controls bit here, I'll explain this first. So the most important register here is NR52 really. NR52, that there is 128 in decimal, which corresponds to bit 7 here. So bit 7 on the sound channel turns on all the channels, so you need to enable them first by turning it on. So putting 128 into NR52 first is the key to starting everything. Then NR50, what this does is it controls volume specific to each of the left and right speakers. So notice that the left hand speaker SO1 uses only the left hand bytes, if you like, just the values 0 to 7, so only these 3 bits here. And then the other channel uses only the right hand bytes in hexadecimal here. So lots of times when you're actually playing around with some of these things, it actually makes sense to see things in hexadecimal, purely because in hexadecimal it's easier to kind of split the byte into 2 parts. So this is like another volume setting here for the left and right speaker, and then the other register, NR51. This enables the speakers as well, so you've got like a mass. NR52 turns on the channels. NR51 then enables the speakers either side, and NR50 sets the volume on those speakers in the range of 0 to 7. So once you've done that, so always do NR52 first. Then I don't think it really matters whether it's NR50 or NR51 next, but you can use NR50 to control the volume on each of the outputs left and right as well. So now on to the first channel, channel 1. So channel 1 has 5 registers associated with it, NR10 to NR14. As you can see here, NR10 to NR14. So I would say channel 1 is, you can use it for some sound effects where the sweep register is needed, and also as a general music playing channel as well. So the frequency of the sounds on the Game Boy go from 0 to 247, and those frequency values kind of correspond to the frequency of notes on a keyboard or any other sort of musical instrument. So what the sweep channel does is, when you play a frequency, the sweep channel can raise the frequency over time, like that. Or it can decrement it over time. Like that. So it all depends what frequency you actually set the sound to. So the sweeps, so you've got the bit flag here, bit 3 of NR10, controls whether the sweep increments or decrements over time. And you've got like a time here as well. So if I come up here and then we play around with the sweep register here. So first off, I'll have to set this to the maximum value here. So the envelope register, which I'll cover in a moment, the init part of that is in the range of 0 to 15, and that's the start volume of the sound. So that's at the maximum volume there. So at the moment the sweep register is set to, bear with me a minute, I'll just scroll up. So 0 indicates addition, which means that when the sweep mode is enabled, or rather when the sweep registers are enabled, I think some of the obviously increasing the time increases, as you can hear, it goes on for longer. The amount of shifts changes how quickly the it changes the value used to change the frequency, it seems. I'm not sure whether these are actually operating in reverse, as in bit 7 seems to alter the frequency more slowly than bit 1. So the higher the frequency, when this is set to addition, the less amount it has to work with, because it starts at the frequency and then it can only go up to a maximum of 247. So if you start at a lower frequency, it has more ground to cover. I'm guessing when that's set to 7, that's actually a smaller amount that the sweep is changing by. When you hear that higher frequency, that obviously means it's got to a higher number here. But there's you can kind of use that as some sort of like jump-in sound, I guess. So you'll have to kind of play around with the sweep settings to find some interesting sounds. So now I'll go on to the pattern duty bits. So one thing to notice is as you play around with these things here, you'll see the values changing. So you'll see which byte these flags actually live inside, and then all of this kind of corresponds to the bits which are in these bytes as well. So each of these registers only can hold 1 byte. So the pattern duty flag here these kind of change how the sound actually sounds over time. Each sound does have a slight different sound to it. when you change the pattern duty. And then there's the sound length as well, but you need to sort of change another register here as well to kind of enable the sound length. So the volume envelope I will go on to next. So the way this works is kind of like the sweep register. There is the envelope register here, which is in NR12. So you've got the initial value, which is the kind of volume, which is between 0 and 15. Then bit 3 controls whether the envelope goes up or down over time. And then you've got the number of envelope sweeps, which is how many times it will adjust the volume by. So this also affects the volume at the end of the note as well. So when it is set to go down, so usually when you have that set to 1, it's best to set this one to 1 also, so that it kind of switches off the sound over time. All these things are best to have a play around with to find what's useful for you. So the most important, well, some of the important things to note here is in the bottom 2 registers here. So because the frequency can be between 0 and 247, it means it obviously won't fit in 1 byte. So it shares the bits that make up that value with the next byte as well. So as a result, the last byte has the high bits of the frequency, as well as other flags which enable the sound itself. So what you'll find is you always have bit 7 enabled on NR14, otherwise you won't hear anything. And then you'll always have the upper bits of the number in here, and then you'll have the lower bits in NR13. The more you play around with these, the more you will be happy with how things actually go. So I'll cover the second channel now. With all these things, it's a case of playing around with them will get you more familiar with how they kind of work and what uses. So I would say channel 2 is pretty much only useful for playing music notes really. So if we go to channel 2, you can see its registers here. So it's only got 4 registers, 2 1 to 2 4. So it's got the pattern duty, which changes the kind of sound of it. And then it has an envelope as well. So if the envelope mode is you can hear it better with this thing, this example here. So this obviously is a note which is played really short, or one which appears to kind of have like an echo associated with it. So it has a volume envelope as well. I won't go any more into that. I want to get through this quickly to kind of show you my example code, which will be useful to you hopefully. So sound channel 3, this one doesn't have an envelope associated with it at all, or any sweep registers. So according to the pan docs, channel 3 is used to output digital sound from a wave buffer. So it could be used to produce like low quality digitized sound. For my example though, I would literally just use it as another music channel really, or maybe your primary music channel if you want to use sound channel 2 for something else. It has a slightly different sound to it than the other channels, which can be useful when creating music. So I'll now get into sound channel 4. So this is a useful channel for creating various sound effects. It has like it's white noise primarily. So it kind of generates random sort of like white noise. Again, you'll have to play around with all of this. It does have a sound envelope which can help it make some interesting sounds. So one thing I will show you here, if I can actually get it to work. So what I would recommend is when you play around with these things, create like a list for future use in games. So if I reproduce this first explosion sound here, so that one's 0. That one's F5. That one's 81. And that one's 80. as you can hear, that's quite a decent explosion effect there. And then that could be like a something bouncing, like a ball or something. Anyway, definitely have a play around with all of these to create various sound effects, and then make a note of what the registers are here. So you've got NR41 to NR44, so there's 4 registers on the noise channel, and then you can literally come up with all kinds of sounds here. As you can see here, I've been playing around with this for use in my own games. So I will now show you my example, which will hopefully also be useful to you. So I'll show you it running first. As you can hear, there's some music playing in the background as well. So I will now show you the code for that. So this is the sound manager code that I will be making available to you here. So I'm just going to quickly go over the key sort of functions for you to use here. So if I open up I'll show you the main sort of program here. So it's got some simple text printing stuff here. So the key thing about using the sound player code here is you have to initialize it first. The initialize function, literally, like I said in the previous part, you turn on NR52 first, and then set the volume for the left and right speaker parts using NR50. I use these 2 variables here to set the speaker volumes left and right, and then I dynamically change the volume over time for the speakers as I need them. And using NR51, I'll use the settings to turn on or off a speaker for an individual channel to limit the sound. So when you use the gbdk's example program to create your own sounds, you can use these commands here to play those sounds using the bytes that they supply, by literally just using sound V1 for the first channel, V2 for the second, third and fourth for the noise. these other commands here are for playing music on the using the voices. When you play music, you kind of need to leave the channels switched on when playing notes and then switch them off afterwards. So once the sound is initialized, it calls sound update each time through the update loop, which is used to play the music. And then the way that the music works is, first I'll show you this. So this is an array here of the values needed for individual notes. And then if I bring up this one here, so you've got this array here of frequency numbers, and then this here corresponds to the index in this array. So you've got the note and the octave, which is the pitch of that note. So C3 would be a very low pitch on C. So you see that there's octaves in the range of 3 to 8. And these are some sounds for the drum effects here. So you see these 4 bytes actually correspond to the 4 bytes needed by the noise channel to make that sound. So it references one group of 4 bytes here. And obviously to play notes we need note playing delays as well, which is what this is here. So if you're familiar with how music is played, each symbol on a note has a delay associated with it. I'll see if I can bring up an image now to kind of explain that. So this is probably the best one here I can show you. So if you look at sheet music, each note on it corresponds to like a pitch, which is how high or low that note actually sounds. So when looking through sheet music, using this image here, you can determine which octave that note is actually supposed to be played at, which is pretty useful. And then another useful thing as well, if I open up another image here, is this one here. When you also see the notes as well, the shape of the note tells you how long it should be played for. So using these 2 images here, you can kind of decipher how these things should actually be played. And then once you have an idea of what that sound should actually be, you can then kind of create a list like this. So this is the Star Wars music here. So to play a note, the format that's expected in the music is you have a play delay, which is how long that note will play for, and then you have a rest delay, and then you have the note that will actually be played, and you just create a list of them. So to play all of these music tunes, you need 3 bytes per note. One is the play sound, one is the rest time, and one is the actual note. And then at the end of it, that value there corresponds to this here. So if any of these values equals to end, then the song will stop playing. So this is just an example to show you how you could play your own music. The problem is these play and rest times are somewhat variable, because music sound times are not sort of set either. You kind of have to play around with each note to kind of get it to sound how you expect it. So if I show you this other image here, so this is the free sheet music I found for the Star Wars theme tune there. So this symbol here shows you what sort of octave it's going to be on. And then you've got the shapes of the notes here, so the shapes kind of give you an indication of how long each note should be played for. And then you kind of, as someone who doesn't actually play sheet music or even read sheet music, I'm kind of guessing the delays. I'm using visually how it looks on the sheet to kind of get a feel for what the delays and gaps between each note being played should be. So for for music and things like that, you literally just create like an array of sounds that would be played one after the other. So this is the sort of like drum sounds here. You can do the same with drums. So you have like a play time, a rest time, and then a sound to output, which for the drums is this. So this here is this setup here is how you would kind of do sound effects as well, really. You would literally just have like a list of the bytes from those sounds, and then you would just call a function that read those bytes out and then loaded it into the registers here, just like bytes like that. So I'll post up this code for you to have a play around with. Hopefully this will enable you to get started with playing some music, and maybe also getting to grips with some sound effects for yourself to put in your own programs. Most of my future programs now for the Game Boy will include sound, now that I've covered this. Right, that's it for this video. Hopefully that's been useful for you.